Here we are. We have finally made it to Blue Book Earth Structure. So for the rest of this year, we're going to be talking about what Earth is, introducing Earth, talking about what makes up Earth, what Earth makes up, and we're going to be talking about different minerals and rocks, what kind they are, maybe we'll get into the rock cycle, fun things like that. So we're at Unit 1, Introducing Earth, Lesson 1, the Earth's System. After this lesson, we'll be able to identify and describe the main components of the Earth system and summarize the effects of constructive and deconstructive or destructive forces. My Planet Diary, a blog posted by Nicole from Medfield, Massachusetts. This past summer, my family and I went to the Grand Canyon. The Grand Canyon was carved by the Colorado River. It was so cool looking down from the edge and seeing a small line that is the river and the rock layers in all the different colors. I was amazed that mules could carry you down into the canyon. Number 1 says, how did the Colorado River change the landscape that existed before the Grand Canyon formed? Well, we know that it eroded or it carved away, so the river carved away the rocks, which ended up forming the Grand Canyon. What are the main parts of the Earth system? The Grand Canyon is made up of different parts. Rock forms the canyon walls. Water flows through the canyon in the form of a river, which carves away the rock. Animals such as deer drink the river's water, and air fills the canyon, allowing the animals to breathe. All these parts work together, so the environment of the Grand Canyon can be thought of as a system. A system is a group of parts that work together as a whole. Figure 1 shows how air, water, rock, and life work together in another part of Earth. The Earth system involves a constant flow of matter through different parts. For example, you may know that in the water cycle, water evaporates from the ocean, rises into the atmosphere, and then falls from the sky as rain. The rainwater then flows into and over Earth and then back into the ocean. You might be surprised to learn that rock too cycles through the Earth system. For example, new rock can form from molten material inside Earth called magma. This material can rise to the surface and harden on land to form new rock. The new rock can then erode into small pieces. The pieces can be washed into the ocean where they may sink to the bottom as small particles or sediment. If enough of the small particles collect, the weight of the sediment can crush all the particles together. The particles can then be cemented together to form new rock. The flow of rock through the Earth system is called the rock cycle. The constant flow, or cycling, of matter through the Earth system is driven by energy. Energy is the ability to do work. The energy that drives the Earth system has 2 main sources: heat from the sun and heat flowing out of Earth as it cools. Earth contains air, water, land, and life. Each of these parts forms its own part or sphere. The Earth system has 4 main spheres: the atmosphere, the hydrosphere, the geosphere, and the biosphere. As a major source of energy for the Earth's processes, the sun can be considered part of the Earth system as well. Each part of the Earth system can be studied separately, but the 4 parts are interconnected as shown in Figure 2. One of the most important parts of the Earth system is you. Humans greatly affect the air, water, land, and life of Earth. For instance, the amount of paved land, including roads and parking lots, in the United States is now larger than the state of Georgia. For years, the ice in the glaciers at Glacier National Park in Montana have been melting. The melting is caused by rising temperatures. As the volume of ice in the glaciers has decreased, the land around the glaciers has become warmer. The warmer land melts the glaciers even faster. Melting of the glaciers in Glacier National Park is an example of a process called feedback. When feedback occurs, a system returns or feeds back to itself data about a change in the system. In Glacier National Park, the ground around the melting glaciers feeds back warmer temperatures to the glaciers. Feedback can increase the effects of a change, as in the case of warming glaciers, or slow the effects down. Feedback demonstrates how changes in one part of the Earth's system might affect the other parts. For example, the feedback of melting glaciers affects the geosphere, so the ground, the hydrosphere, the glaciers, and the atmosphere, the climate. We learned that Earth's four spheres can affect one another. What they want us to do is to read the descriptions of the Earth's four spheres, and then write the spheres that are interacting with each other on the lines. So atmosphere is our first one. It says Earth's outermost layer is a mixture of gases, mostly nitrogen and oxygen. It also contains dust particles, cloud droplets, and the rain and snow that form the water vapor. It contains Earth's weather and is a foundation for different climates around the world. Earth's atmosphere is the relatively thin envelope of gases that forms Earth's outermost layer. So if we look in this picture, we can see that it is snowing a lot. So we can say the atmosphere is interacting with the biosphere. We talk about the next picture, geosphere. Nearly all of Earth's mass is found in Earth's solid rocks and metals, in addition to other materials. Earth's geosphere has three main parts: a metal core, a solid middle layer, and a rocky outer layer. In our picture here, we see a volcano, looks like is exploding. So the rock that's in the geosphere is erupting into where? The atmosphere. The third one we have is our hydrosphere. About 3/4 of Earth is covered by a relatively thin layer of water. Earth's water can take the form of oceans, glaciers, rivers, lakes, groundwater, and water vapor. Of the surface water, most is the salt water of the ocean. Only a tiny part of the hydrosphere is fresh water that is drinkable by humans. The hydrosphere contains all of Earth's water. So we can see in the picture, our water is brushing up against what looks like some rocks. So therefore, the waves in the hydrosphere are hitting the rock part of the geosphere. And our biosphere. Life exists at the top of mountains, deep underground, at the bottom of the ocean, and high up in the atmosphere. In fact, life exists in all kinds of conditions. But life as we know it cannot exist without water. The parts of Earth that contain living organisms make up the biosphere. We can see this flamingo chilling in our water, probably a little pond. So we know that the biosphere is interacting with the hydrosphere. So, quick recap. Atmosphere talks about the gases and helps with the climate. The geo, so rock, sphere, does rock stuff. Hydro, so hydrogen, water, deals with water. There you go. And the biosphere, biology, animals, living things, deals with living things. How do constructive and destructive forces change Earth? Suppose you left a movie camera running in one spot for the next 100 million years, and then you watched the movie in fast motion. You would see lands forming and mountains rising up, but you would also see them eroding back down again. Lands are constantly being created and destroyed by competing forces. The Himalayas are Earth's highest mountains, but rock in the Himalayas contains fossils or remains of ocean animals such as ammonites. How could creatures that once lived at the bottom of the sea be found at the top of the world? The Himalayas are the result of the collision of two sections of Earth's lithosphere, or Earth's top layer of stiff, solid rock. This layer is broken into huge pieces, or plates, that move slowly over Earth. The slow movement of Earth's plates is called plate tectonics. The Himalayas are the result of the collision of the plate that carries India with the plate that carries China. Over millions of years, as these plates collided, their edges were squeezed slowly upward. This process lifted up the ocean floor and formed the Himalayas, shown in Figure 3. So pretty much what happens is, say you have, put your hands out. Two hands facing each other, flat. I think I can put a camera on actually. Can I do that? Okay. So you have your hand and you have your hand. And slowly, these are two different plates. One of these, this is China, this is India. And over thousands and thousands of years, these plates are slowly coming together. And we can do this where one goes underneath. We can do it where the other one goes underneath. Or, in the case of these mountains, they hit each other and then slowly started coming upwards. They hit and then they kept going higher and higher and higher and higher and higher and higher. So that's how, over thousands of years, our Himalaya mountains, and most of the mountains on Earth were formed. You have to do one of these things. Also, it's really fun to do. I recommend it. Forces that construct or build up mountains are called constructive forces. Constructive forces shape the land surface by building up mountains and other land masses. Volcanoes build up Earth's surface by spewing lava that hardens into rock. Earthquakes build land masses by lifting up mountains and rock. So down here we have Figure 3. And part of it you can't see the questions, but I will read those. It says, from sea to mountain, constructive forces raised the Himalaya mountains. So number one, they want to know, why is ammonite fossil found in the Himalayas? So here we have a picture of an ammonite at the top. We also have a picture on the side of what the Himalayas look like. And then we have a map showing the Indo-Australian plate for around India, our Eurasia plate where we have China, combining together where we have the Himalayas. Well, we can presume that India collided with China. They're playing bumper cars for thousands of years and eventually they crashed into each other. So at that point, as they crashed and started rising, remember, hands hitting and going higher, the ocean floor was lifted up, raising those ammonite fossils to be on drier, higher land. And then over time, the ocean floor faded away and became the Himalayas. Number 2 asks, many peaks in the Himalayas are 7,300 meters or more above sea level. About how high above India's capital, New Delhi, are these peaks? So if we take a peek, we're looking for peaks, so we're taking a peek. Okay. We can see our elevation. Our Himalayas, we see are in like a little, the colors are different. That's what I'm getting at. We can see that New Delhi is somewhere around the yellow area, yellow-green, so 150 to 300. And our Himalayas are at 3,000 meters above sea level. Or higher, that is. So by doing math, if we subtract, we know that the Himalayas are 7,000-ish meters higher than its capital city. So if you're standing on the ground and you look up, and up and up and up and up and up and up. There are your mountains. While the Himalayas are being built up, they are also being torn down. Ice, rain, wind, and changing temperatures tear the rock apart. This process is called weathering. After the rock is torn apart, gravity pulls it downward. Eventually, rivers and streams carry away most of the eroded material. Because forces such as ice, rain, wind, and changing temperatures wear down or destroy land masses, they are called destructive forces. Destructive forces destroy and wear away land masses through processes like erosion and weathering. Erosion is the wearing down and carrying away of land by natural forces such as water, ice, or wind. Apply it! Since 1983, lava from Kilauea has covered more than 100 square kilometers of land in Hawaii. Here, lava flows into the Pacific Ocean. When it reaches the water, it cools quickly. The cooled lava hardens to form new rock. So the forces that cause lava to erupt, would they be constructive or deconstructive forces? They would be constructive forces. Number 2 says, other than the weather, what force wears down the new rock formed by the magma from Kilauea? Well, besides the weather for wearing down the rock, we also know that the waves, because we're on an island here, the waves from the ocean are hitting the rock, and over time would be wearing it down. Boom! There we go. There's our introduction to what Earth is and the different spheres that Earth has. On Thursday, we're going to be talking about Earth's interior. So the inside of Earth, what makes up the inside of Earth, not just the outside of Earth. There's a worksheet ready for you to go. I will see you tomorrow for social studies.